Okay, today we're going to be talking about section 8.5, which is adding and subtracting rational expressions. Yesterday we multiplied and divide rational expressions. Today we're going to add and subtract them. Now whenever you add two fractions together, the first thing that you need to remember is you need to get a common denominator. So a lot of the rules that we did yesterday are still going to apply to what we're doing today. So when you add two fractions together, you have to get a common denominator between 2 and 3. So my common denominator between 2 and 3 is going to be 6. When in doubt, if you don't know, just multiply the two of them together. So this is going to give you a 6 here and a 6 here. What did I multiply 2 by to get 6? A 3. So 3 times 1 is what I'm going to be doing at the top. What did I multiply 3 by to get a 6? A 2. So that's going to be 2 times what's left on top to give me 3 6 plus 2 6, which gives you a 5 6. Okay? So that is how you're going to add two fractions together. Now, this right here is the entire step-by-step procedure that you're going to be doing, and I'll try to follow along with that to make sure that you guys are doing it. I know this is going to sound a really stupid example, but I feel like whenever I use this example, it's really a good example for people to understand how we do this, okay? So step 1, we are going to factor each denominator with GCF into two binomials if possible. We're going to find the LCD. Okay, boy meets girl, boy likes girl, we meet each other. Then we're going to write each fraction with the same LCD, meaning that you are now a couple, okay? Then when all the fractions have the same denominator, you're going to write it as one fraction, meaning you're engaged. Then you're going to write the fractions in with one denominator, meaning now you're married and you're in one house, okay? You're going to get rid of the parentheses, and you're going to unpack all your boxes, which means you're going to throw away anything that are doubles, okay? You're going to combine like terms. So this is going to be your combine like term phase, okay? You don't need two toasters, you don't need two blenders, so you're going to toss out the boxes. You're going to combine like terms, and in the numerator, you're going to factor out the GCF and put it into two binomials, just like we did before. And all the things should be factored in the numerator and denominator once it's completely factored. And then you're going to find the domain restrictions by setting each term in the denominator equal to 0. Now, I'm going to be honest. Right here is normally where I find my domain restrictions. I do it at the very beginning. As soon as I find my LCD, I find my domain restrictions. That way, I'm never forgetting. However, whenever I come down here, I then can look at that and remind myself, did I find my domain restrictions? The answer to that will be yes. And then I'm going to cancel out any like terms that I have from left to right that are in both the denominator and in the numerator. And then this is your final answer. So let's go ahead and do this. So step 1, I need to factor each denominator completely. So I'm going to look at these two things, and I'm going to first immediately check to see if they're attached by addition or subtraction. If they're attached by subtraction, I'm going to immediately change it to addition and distribute the negative to the term on the right's numerator completely. Okay? In this case, it's attached by addition, so I don't need to worry about it. So I'm going to have x over x minus 1 because I cannot do anything with this one. My numerator, I keep exactly the way it is. I don't touch it. But this denominator, I need to factor into two binomials. I'm going to have an x and an x. I'm going to have a 1 and a 2. I need to get a 3, but I have to have a positive 2, which means my signs are going to be plus plus or minus minus. My middle term is minus minus, so that's why I'm going to be using that. So from there, I'm going to find my LCD. My LCD is going to be, my denominator is going to be the x minus the 1. These already have an exponent of 1. If it would be 2, I'd take the higher exponent if they were different. So if this one would be 2 and this one would be 1, I'd take the higher exponent. Okay? In this case, they're the same, so that's why I only need one of them. So this is my entire LCD, which means my domain restrictions are going to be x minus 1 cannot be 0, and x minus 2 cannot be 0. So x cannot be 1, and x cannot be 2. Okay? Always keeping those there. All right? So now, I have to get each of these. Boy meets girl, they have to get the same denominator. They like each other, so we're going to have each one of these have that denominator. They are attached by addition. Okay? So what did I multiply this first denominator by to obtain the new denominator of x minus 1 times x minus 2? What I tacked on was going to be a drop down what it currently has, which is going to be an x. And then I'm going to tack on what I tacked on in the denominator, which was x minus 2. Now look at the next one. What did I tack on? I didn't tack on anything, so I just dropped down what is currently there. So now that I have the same denominators, I'm going to go ahead and write this as one fraction. So my one fraction has the one denominator, and then I bring his stuff, distributing that, x squared minus 2x, and then her stuff just dropped down to 2x minus 1. From there, I'm going to combine like terms. So I'm going to unpack all my boxes. So if I unpack all my boxes and combine my like terms, I'm going to get an x squared minus a 1 all over x minus 1 times x minus 2. I'm not done because now this is a problem from 8.4, because now that it's one fraction, I can go ahead and treat this exactly like I treated all my last 2 homework assignments. So I need to factor that numerator completely, so that's going to give me an x plus a 1 times an x minus a 1 all over x minus 1 times x minus 2. Then from left to right, I'm going to cancel out what is in both in common. Do I have an x plus 1 in the denominator? I do not, but I do have an x minus 1. So what is left is x plus 1 over x minus 2. And that is your final answer. Okay? A lot of work, okay, but it's completely doable. So let's do this again. New example. Very first thing that we're going to do is we're going to find the denominator. We're going to factor into 2 binomials. First, I check to see, is this attached by addition or subtraction? It's attached by addition. So all I'm going to do is factor this into 2 binomials. This is the difference of squares. So I know immediately what that is going to factor into because we've done that a ton of times. The next thing we're going to do is we're going to find the LCD. The LCD is going to be the x plus 2 times the x minus 2. I only need 1 because they both have an exponent of 1. Each of those have an exponent of 1. So my domain restrictions is going to be x plus 2 cannot be 0 and x minus 2 cannot be 0. So x cannot be negative 2 and x cannot be positive 2. Okay? So now I need each of these denominators to have the new denominator of x plus 2 times x minus 2. Because we want to signify that these are 2 fractions that have something in common. So we're going to go ahead and we're going to say, okay, well, if we look at this fraction denominator here at the top in blue, what did I do to the blue denominator to obtain the green denominator? And I did nothing to it, so I just simply dropped down the current numerator. Go to the second fractions denominator. I have only an x plus 2, but to turn it into the green denominator, I tacked on an x minus 2. So I drop down the 1 and I tack on the x minus 2. If you start canceling out, you're going to go backwards, you're going to go to the original problem. You do not want to do that. So now I notice that I have 2 fractions with exactly the same denominators. So that means I can simply write them as one fraction. So if I write them as one fraction, I'm going to have x plus a x minus a 2 all over x plus 2, x minus 2. Combine like terms, that gives me a 2x minus 2 over an x plus 2 times an x minus a 2. So from there, this is now an 8.4 problem. It's attached by multiplication, so I'm going to factor the numerator completely and the denominator completely. So I'm going to continue on. Maybe. Factor out a 2 because that's your GCF, and I'm going to be left with an x plus 2 times an x minus a 2. Now, do I have a 2 anywhere in the denominator? I do have 2's, but they're inside of an expression. The x plus the 2 is attached as the head and the body. I cannot separate them. They go as one unit. X minus 2 goes as one unit, which means that's as far as I can go, and that problem is done. Okay? Let's do it again. Now, let's look to see how are these 2 fractions attached. These 2 fractions are attached by subtraction. So I'm going to immediately change that subtraction to an addition, making that 2 become negative. Okay? It's going to make everything so much easier for us whenever we continue on. So with that being said, I need to go ahead and factor each one of these completely. The x minus 1 is already factored. And I'm going to pull out a GCF of an x to give me an x minus a 1 here. So from here, I need my LCD. My LCD is going to be x times an x minus 1, which means my domain restriction is x cannot be 0 and x minus 1 cannot be 0. So x cannot be positive 1 or 0. Now I need each one of these fractions to have the new denominator of x times x minus 1. So I'm going to write that down twice because I have 2 fractions. So let's look at this very first denominator. What did I multiply x minus 1 by to obtain the blue denominator of x times x minus 1? Well, I multiplied it by an x, and then I'm going to simply drop down the current numerator, which is x plus 1. What did I multiply this x times x minus 1 green denominator by to obtain the blue one? Nothing, so I just simply drop down the minus 2. So now I have two fractions that have exactly the same denominators, which means I can marry them and write this as one fraction. So I'm going to distribute this, x squared plus x minus 2 all over x times x minus 1. Again, now I have a numerator denominator. This is an 8-4 problem, so I'm going to go ahead and factor the numerator completely. So this is going to be an x and an x. One has to be positive and one has to be negative because I need a negative 2. But I need a positive 1, so the 2 is positive and the 1 is negative, to give me an x times an x minus a 1. So from left to right, do I have an x plus 2 anywhere? I do not. Do I have an x minus 1? I do. What am I left with? X plus 2 over x, and that is done. Okay, now, whenever we have a fraction divided by a fraction, it's really nasty and ugly. So what we're going to do is we're going to separate this, and we're going to write this horizontally. When we write this horizontally, I'm going to have the new problem, which is going to be 4 over x squared minus 1 divided by 3 over x plus 1. Looks a whole lot easier already, because now this is an 8-4 problem. An 8-4 problem is where I have two fractions attached by multiplication or division. So what I'm going to do here is I'm going to keep, change, and flip. Keep, change, flip. I keep the first fraction, I change the division to multiplication, and I flip the second fraction. So from here, I'm just going to do an 8-4 problem, which means I'm going to factor each one of these denominators completely and the numerators. This is the difference of squares, and this stays. Okay? So from left to right, I'm going to start canceling things out. Do I have a 4 or a multiple of 4? I do not, but I do have an x plus 1, so I'm left with a 4 over a 3 times x minus 1. That problem looked ridiculously hard at the beginning, but truly, it was very simple and probably the easiest problem that we've done so far today. And I got you ready for that because this is the nasty problem that we're going to do. Okay? So we have a fraction plus a fraction in the numerator divided by a fraction minus a fraction in the denominator. So we are going to do exactly what we just did with the other one. And we're going to rewrite this, and we're going to make this an x minus a 2 over x plus a 2 over an x plus 1 divided by, this is going to be 3 over x minus 1 minus a 1 over an x plus 1. Okay, so I wrote this in different colors for a very specific reason. I have two problems I have to do. After I simplify this fraction, these two fractions and write it as 1, and simplify these two fractions and write it as 1, I then can do keep, change, flip at that point after I get down to two fractions. So the very first thing we're going to do is we're going to work this purple one here. This is already factored completely, so my LCD is going to be x times an x plus 1. So I need an x times an x plus 1 here, plus an x times an x plus 1 here. So what did I multiply x by to obtain an x plus 1? Well, I tacked on an x minus 1. So I dropped down what is currently in the numerator, which is x minus 2, and I'm going to tack on the x plus 1. What did I multiply x plus 1 by to obtain x times x plus 1? An x, so I tack that on. I'm not even going to acknowledge the rest of the problem right now. I'm just going to keep on working because my brain is focused on this part right now. So I'm going to write this as one big fraction, and I'm going to FOIL this. X squared minus 2x plus x minus 2 plus 2x. Again, I'm going to keep on going with this problem, combining like terms. Those cancel out, and I'm left with an x squared plus an x minus a 2 over x times x plus 1. Keeping going, I'm going to factor this into two binomials. X plus 2 times x minus 1 all over an x times an x plus 1. Okay, so what I've essentially done is I have completed this entire purple problem all the way down. Okay? So I'm going to bring down the division key all the way down. Okay, now we're going to work on the green problem. My green LCD is going to be what? X minus 1 times x plus 1. Okay? So now I have to have two fractions with that denominator. My board is very slow. So what did I multiply this x minus 1 by to obtain the new green one? I tacked on an x plus 1. So I'm dropped down what's currently there, and I tack on the x plus 1. Go to the second part. This becomes a plus negative 1 there. Okay? So I tack on the negative 1, And I'm also going to tack on what I tacked on in the denominator, which was the x minus the 1. Okay? So I'm going to write this as one fraction now. X minus 1, x plus 1. I'm going to distribute 3x plus 3 minus x plus 1. Still attached by division. I'm going to combine like terms. 3x minus x is a 2x. 3 plus 1 is a 4. All over x minus 1 times x plus 1. Then I'm going to factor this completely, so I'm going to pull out a 2, so that gives me an x plus 2 all over x minus 1 times x plus 1. Okay, so this is where I'm at this point. I have two fractions completely factored, attached by division. So from there, I'm going to keep this fraction, x plus 2 times x minus 1, all over x times x plus 1. I'm going to change the division to multiplication. And I'm going to flip the second fraction. So that's going to be x minus 1 times x plus 1 in the numerator, all over 2 times an x plus a 2. Okay? Now from there, I'm going to start canceling things out. Do I have an x plus 2 anywhere? I do. Do I have an x minus 1? I do not. Do I have an x minus 1? I do not. Do I have an x plus 1? I do. Okay? So how many x minus 1s do I have inside here? I have one there and I have one there to give me a total of x minus 1 squared all over what's left down here is simply a 2x. And that is as far as you can go, and you are completely done. And that was a big problem, but if you take it in steps the way I did it, you should be fine completing this. Take the first fraction and write it all the way down. Take the second, write it all the way down, combine them, and you'll be good to go. Tonight's homework is 8.5, worksheet 1.